Today, class, you're going to be learning about relations and functions. A relation is a set of ordered pairs, so it can be anything that's paired together, an x and a y. Now, there's several ways to describe a relation. One way you often see it described is a list of ordered pairs, where you have your x value paired with your y value. Another familiar way to use should be when you see it in a Cartesian plane, or a coordinate system, as you may call it, where you have your x and y actually graphed. Then we have what's called a mapping diagram, where they give you your x values and they map your x values to your y values. This is also a relation. Now, when you think of relation, just think of the word relationship. You can also have the data displayed in a table where it denotes your x as well as your y, or they could have given you an equation, and the equation where you plug in your x, your domain, to find your range, or plug in your range to find your domain. Now let's talk about those two words, domain and range. A domain of a relation is the set of input values. So your input values are your x values. And it's also your independent quantity. Then you have your range, which is the relation, is the set of output values. So you have your output values, which are your y values, and that is your dependent quantity. And we'll go over that a little bit more in class. So now, looking at the relation above, I want you to find the domain and the range. So if you recall, I said that the domain was going to be your x values. So if I look up above, I can see all my values of x, and that's what I'm going to plug in. Now remember, you never put these in parentheses. So I'm going to have 0, 3. I have another 0, but I don't ever have to repeat it. And then I have a 4. So that would be my domain. So then I would do the same for my range. So here my range values would be -2, 2, -1, 1, and 0. So I'm going to denote those here. -2, 2, 1, 1, and 0. Okay, and that should be a -1 even if it didn't show up on your screen. So let me try to put the little negative sign there. There we go. Okay, now let's flip over to the next page. So now we're going to talk a bit about functions. Now the difference between a function and a relationship is a relation is anything that's paired together, your x and your values. But in order for it to be function or functional, you can only have one y value to that x value. So I want you to underline here that no x coordinates are used more than once. No x coordinates are used more than once. That's very important. If your x coordinates are used more than once, then you do not have a function. So let's look at the examples on number 2. So I have my x values. Let's go ahead and mark our x values. So I have a 0, a 0, a 3, a 3, and a 4. Because an x value is used more than once, then no, this is not a function. Now let's look at the next one. So for the next one, I have a 1, a 2, a 3, and a 4. Because none of my x's are used more than once, this is a function. Now some of you are probably saying, well, Ms. B, my y values are used more than once. This is true. I have the y values used more than once, but by definition, it's just my x values that can't be used more than once. So that doesn't stop this from being a function. Excuse me. So now let's look at number 4. Now sometimes that's a little bit difficult to see, so it's best to write out your coordinates. So what I really have here is 1 paired with 3, 1 paired with 4, and 2 paired with 3. So now I'm going to go back and I'm going to look at my x values. Did they repeat? Yes, my 1s did, which means what? Correct. This is not a function. Now let's go look at number 5. So on number 5, I'm again going to look at my x values. Did any of those repeat? That would be negative. So yes, this is a function because none of those repeated. So now the next way that we tell whether or not something's a function, and this is very important when you have a graph, it's your vertical line test. So for the vertical line test, I have to be able to draw a vertical line. And don't get confused by that. A vertical line, remember, goes north and south. I have to be able to draw a vertical line and only touch through one point on the graph. I cannot intersect my graph, which is my drawing, more than once. So if I were to draw a vertical line at any point on this graph, it would only hit once. So I can denote that, yes, that is a function. Whereas on the next one here, if I were to draw a vertical line, I'm going to hit this graph there, and I'm going to hit it again here, which tells me no, that's not a function. Now looking at this last one, it's a little bit hard to see, but if you note these 2 points, okay, let me try that again. These 2 points are right over each other. So if I were to draw a line through that, it would touch both of those points. So what does that mean? It means that no, it is not a function. Now let's look at number 9 and 10. What we're doing on 9 and 10 is we're giving you an equation, 5x minus 1. And I want to know what is the value of this when I plug in x, or 10 for x. Let's talk about how I know to plug in 10 for x. I have a 10 here, and I have an x here. So that's telling you that you substitute this value for your x. So when I plug that in, I'm going to have 5 Okay, I'm having a little difficulty writing here, so let me try that one again. I'm going to have 5x minus 1. And I'm going to substitute my value of x. So remember, whenever you do that, you're going to put a set of parentheses. And I'm going to plug in my 10. And 5 times 10 is 50, minus 1 would be 49. So my indicated value would be 49. Excuse me. So I'll give you a minute to get that down before we go to number 10. So let's look at number 10. If you didn't get that part, just rewind your video in a minute and you can copy number 9. Okay, so for number 10, my equation is 2 plus x squared. So what I have here is 2 plus, well, I'm going to put parentheses for that x, and I'm going to plug in my value of x, which in this case would be negative 3. So I know that negative 3 squared is going to give me 9, because negative 3 times negative 3 is positive 9. And then I'm going to have 2 plus 9 and that's going to give me 11. Excuse me, I'm having a little pen difficulty here. That's going to give me 11. Okay, let's go to the next page. So here it wants you to state the domain and range of the following relations and determine if it is a function. Okay guys, we're going to stop here. This is where we're going to pick up in class. It's really important for me to get you to see why I'm going to tell you tomorrow that both of these would be all real numbers, or negative infinity to positive infinity. But that's a conversation I really want to have with you in class. So you can go ahead and stop here, and I hope you took good notes, and I'll see you tomorrow.